Hello everyone and welcome back to the Houdini Online Fundamentals class. Now that we have spent so much time looking at the basics with Houdini, and I'm talking about kind of the underlying foundation of Houdini, nodes, parameters, connections, networks, etc. And we've done a little bit of Houdini work with how to create simple objects, transform those objects, parent those objects. Let's move in to some cool stuff. So in this video, what we're going to do is we're going to introduce you all to basic polygonal modeling. And the way we're going to go about doing this is we're going to cover about 10 or 11 nodes that we can use for polygonal modeling. And Steve is going to give you some very basic demonstrations of how these nodes work. And then in the end, we're going to model out some sort of simple object that we can later animate. We'll do a very simple jet. And I'm saying very simple for the simple fact that when creating a model, one can easily spend hours. And the idea of these videos are not for us to go in there and spend hours demonstrating something if we can get in and out quickly. So we'll make a very simple jet, maybe throw some missiles on it so that we have some neat things to animate a little bit later on. So that is the goal. Now, another interesting thing about the approach we're taking with this video is that Steve will be demonstrating how to use the tools more so than coming over here and just constructing a network. And what's going to happen is as we use the tools, you will see over in the network editor that Houdini will be constructing a network for us, and that is pretty neat. Now let's jump over to the whiteboard, because we can't start a lesson without some good whiteboarding. So once again, we will be doing some basic polygonal modeling. There are a series of sops that we're going to be looking at, and let's go ahead and do a real quick review. Sops, when you hear that, we're talking about surface, operators, now, when working in Houdini, we know up at the object level, we're going to be creating a geometry node. So here's a very simple geometry node. Now, we all know that we step inside that geometry node, and when we do, we are now at basically a surface context. We're working with surface operators to construct geometry. So from here, basically, we now step inside, and then we're going to create a series of nodes, and these nodes are all going to work together in a network to create some sort of geometry. So here's one way to draw it. Another way we could go about drawing it would be like this. Here is our geometry, and inside is a crazy network that, wow, that is a crazy network, that forms our final model. And that's really what I want you to think about. Geometry node is an object, or our model. Okay, so keep that in mind. Now let's start talking about the different sops that we're going to be looking at in this video. First of all, we're going to start out with some simple stuff. I'm going to write all of these out first, and Steve's going to mention real quickly as I'm writing what each one does. Then we're going to back up, and we're going to jump into Houdini and demonstrate each of these. And then after demonstrating everything, then we're going to go back in there and do some modeling. Cool. It's all about having a little bit of fun. Oh, yeah. So we'll start out with a box.
Well, a box creates a very simple polygonal box.
It's a generator sop.
It is a generator sop, which means it takes no inputs, but it gives us out some geometry.
Outstanding. And it's a great way to start a model so that we start with something to work from. So, and you'd be surprised, for those of you that are completely new to modeling, what one can do with a box. Oh, yeah. You could end up with Gollum's head with just a box.
A lot of modelers do just use boxes as their starting base.
And you'll use the term, or you'll hear the term, box modeling often. And it's because they're starting with a box. All right, from there, we're going to be looking at we got two different ones to look at. Well, let's start with poly extrude.
Poly extrude is an interesting one to explain. It's probably easier to explain with little diagrams than just through English. Fantastic.
So here we are with a polygon. So this polygon is made up of components, as Steve has already mentioned when we went through the selections video. So we've got points. So here's all of our points. And then connecting all of the points together, we have a series of edges. And we know that once we have edges running all the way around with 3 or more, we can create a polygon. So we end up with what is generally referred to as a face, or a simple primitive, if you will. Yeah. So here we are with a face. The idea of poly extrude is to allow us to take a face and extrude it. And here's what I mean. Let's say we take this face right here, and we tell it to extrude out. what's going to happen is, pretend we can take this face and truly pull it out like such. But when we do, we leave it connected back to the geometry that we're pulling it out from. So that means new faces will be created. So what's going to end up happening is this guy's going to get extruded out, and it's going to look like this. So here we are with the face. Okay, a little off.
Close enough.
All right, no, far enough off that it's going to drive me crazy.
Okay.
I got to fix that.
Cool.
I don't know about you, but that's just driving me
I guess
nuts.
it will make everything nice and clear.
So I'm just going to redraw that face further out here. So basically, like such. So because we've extruded it out, and then it's connected back like such.
Cool.
And now let's clean it up because you're not going to see through it, obviously.
Yeah.
So we end up with, you're not going to be able to see all that because we have new faces. There we go. Won't see any of that. You won't see any of this stuff down here. And so by doing a simple extrude, we have done the following. And this gives us additional geometry that we can then work with. I mean, I can take this top face right here and extrude it upwards, which would then allow us to do something like this. And then once again with the eraser, if I was to come in here and clean this up. So with two simple extrusions, you can see we've already made quite a change. Whoops, let's not do that. Quite a change to our model. Okay?
Cool.
So extrusions are a very powerful way of taking a box and quickly turning it into something that no longer looks like a box.
Sure.
All right, next thing we're going to look at, and a very important tool, is the poly extrude. I'm sorry, poly split. Steve, you're supposed to smack me. Okay?
Sweet.
So with the poly split, what we can do is we can come in and split a face. Basically, we can add additional vertices or additional points and edges. So if I wanted to add some more detail, let's say that this guy right here, I wanted to split him in half so I could extrude a smaller section of that particular thing. Oh, not a problem. I could come in here and do a poly split from there to there, and we can add an extra edge in.
So we add additional vertices, and through adding additional vertices, we're going to be defining new edges. You also have the ability to split from an existing vertice to either another existing vertice or a newly created vertice as well. And we'll demo that in a second.
Okay. Next thing we're going to look at, clip.
The clip is a way of deleting a lot of geometry quickly. Mm-hmm. It allows you to delete geometry that falls on one side of a plane, and you get to specify that plane that will be used as the clipper.
So if we came in here with a box, and let's go ahead and draw it in perspective view, and with this box, let's say that we want it to model only half of it, and then later mirror that half over to the other side. So, you know, we basically reduce the amount of work we have to do to complete a model. We can use the clipper to come in here, or a clip sop, and with the clip sop, we can basically say, all right, everything on this side we're going to eliminate.
Yeah.
Okay. All right, moving on from clip, next thing I want to look at is going to be blast.
Blast is another way of getting rid of geometry. In this case, Blast allows you to make a selection of geometry and delete just that selection.
Okay.
And it actually works by selecting geometry, and interactively, if you just push the delete key, that actually uses a blast node to do
Absolutely.
that.
Houdini's smart enough to throw that blast node in there. All right, next thing we're going to look at is going to be the, let's see, polybevel.
Cool. So polybevel works on edges. And to bevel an edge, effectively you take that edge and you take a duplicate of that edge and you space them out slightly. And what that's going to do, that's going to give you instead of having a razor sharp edge, you're going to have a small face where that edge used to be that sort of rounds out the model very slightly.
So instead of a corner that looks like such, we could end up with a corner that looks like...
Very nice.
Such.
Exactly, and you can see you've got rid of that razor sharp edge that we had on the top image.
This is the razor sharp edge he's talking about, which is now gone right here. And this really is important. This is where the beginners in the world of modeling forget the importance of beveling. You really need to get rid of as many sharp edges as possible, because in the world in which we live, it's very difficult to find objects with razor sharp edges. I'm looking around the office right now, and I can't see one thing, Steve, if you can,
I can't see.
that has a
No.
razor sharp edge on it. And so why is it important? Well, I mean, what makes it a problem in CG? Well, with a razor sharp edge, you cannot have a highlight that falls across that. But if we bevel it and there's another surface in there, just a real small surface at an angle, we can now have just a little bit of specularity get picked up. And that right there adds so much, and it's subtle. That's the beautiful thing. When somebody has a perfect, crisp model, everything's hard, razor edge, and somebody looks at it, it just doesn't look right.
Yeah.
And the reason it just doesn't look right is because, once again, the world in which we live, everything has some sort of beveled edge. Otherwise, you'd get your fingers cut on everything you worked with in the room.
Look around the office and look at all these different things that we can see highlights on. The edge of the monitor, highlight.
Yep.
Top of the stereo, highlight.
Yep.
Everything has highlights, and that comes from the fact that they don't have razor
My
sharp
forehead,
edges.
that's a pretty big bevel, though. Okay, so yeah, beveling, very important. All right, so now let's get into some simpler stuff. Edit. Edit's critically important because you're going to find yourself needing to manipulate points, edges, etc., going in there and grabbing these guys and moving them and rotating them.
Say you've got your model to a certain point and you wish to move a certain selection of components. You'd grab those components and move them, and it's going to use an edit sop to do that.
Yeah, so if I wanted to take these points right here and just simply move them back so that we end up having something that looks, let me see if I can come up with an example, something that looks like this. Yeah, okay, that looks really bad. But this guy's been moved all the way back here, like such. You'd use an edit sop to do this. And you can use, and here's another nice thing with the edit sop. It's not that you can just move one selection of components to where you want. You can then grab more and more and more, and all of that can be stored in that one edit sop. So that's really nice. Okay, so let's take a look at some other things. How about the ability to mirror?
Well, we spoke about how useful mirroring could be earlier when we talked about splitting that box in half, which is, fantastic.
So I'm splitting it for you.
And then, say we've modeled all of that side and we've got that perfect to how we want our model to be, we can then take it, mirror it about an axis, so about a plane, and that will allow us to then basically duplicate that to the other side, so we now have both halves of our model, and it will weld or fuse, is the term in Houdini, the vertices together that run along that center plane.
And what's really nice then, of course, is we're working on one side. If you end up going back up working, the other side's just going to be automatic. So, you know, something like a human head. Yeah. It would be nice to just model one side of a head and have the other side just automatically complete it for you. Then, of course, it's an asymmetrical type model, so you'd want to go to the other side afterwards and maybe make some slight adjustments with an edit sop.
But a lot of things that you would model would definitely start out as symmetrical objects.
Yeah, like our jet. Our jet better be symmetrical all the way around.
It's going to have problems flying.
That's right. Okay, so mirror, let's see what else we got. Fuse. Ooh, that's a good one.
So yeah, fuse, as we briefly just skimmed on with the mirror, fuse allows us to join vertices together. Say we have two vertices that lie in the same location. If you fuse them together, you'll now just have one vertice with the edges that ran to those two original vertices running just to that one vertice.
Let's draw this a little differently. Let's say we just simply had something like this. So we're looking at 4 vertices right there, but there's a space between here, right? We can come in here. Basically, fuse is like bringing a welding torch to the party.
Yeah, it really is.
So I can take these two guys if I wanted to and say, all right, let's fuse those together, and we can specify basically a threshold.
Yeah.
All points within this threshold will get welded by the torch we've brought to the party. So we'd end up with something that, in this particular case, would look like this, because I did not apply it to the back two.
So you end up with just a single vertex, where before we had a selection of vertices.
Yeah, because just moving these two on top of each other wouldn't do us any good, because it'd still be 2 points. It would just be 2 points on top of each other. And one of the things that you will see Steve do as we begin modeling is show points. We can show points, we can show point numbers. And when we start showing point numbers, if this ended up being point number 5 and this ended up being point number 10, you'd end up with, so if you had 2 points on top of each other, so there's 2 on top of each other, and you looked at point numbers, you would have a 10 and a 5. It would just be a mess.
Yeah.
And this is something we will be seeing in this video. Okay, so fuse, let's see, what else do we have? How about edge cusp?
Edge cusp is interesting because it has kind of like a technical definition, and then it has a sort of English language definition as to the effects that you really see. And the technical definition is that edge cusp is going to give each of our faces a unique set of vertices. So whereas we were talking here about fusing vertices together, we're now talking about each face, the vertices that belong to a face are unique to that face. And that means none of our faces are joined together. And the direct result of that and the visual result of that is we now have hard edges between every single face.
Exactly. And again, that's going to be demonstrated coming up here real soon, so it'll make a lot more sense. Finally, the most complex of them all, since I want you to make a missile, we're going to have to introduce a tube.
Fantastic. So again, another generator sop. This guy, instead of generating a box, he's a tube, so he generates a tube.
Exactly. Now, there are two modeling styles that we're going to be focusing on, one in this video, then one in an upcoming video, just a few videos from now. This particular video is all about basic polygonal modeling. This means we're not going to be using the true power of Houdini, which is proceduralism, the ability to create something that we can then just easily manipulate and it just, takes care of itself. It's procedural. So in this case, Steve is going to be doing straightforward modeling, kind of like the modeling that you would do over in 3ds Max, Maya, or other 3D applications. Now, coming up shortly, we're going to be taking a look at procedural modeling, and this is where we will begin using expressions and referencing various parameters and even adding our own custom parameters so an artist can use a series of sliders to get the look that the artist is looking for out of a particular model. And that's where we will finally get to see everything we've talked about in the fundamentals class all come together.
Cool.
And I just wanted to point that out so that when we come back to modeling again, everybody understands what it is we're doing. And you guys have already seen the model that we're going to walk you through. That's that stool model that we demonstrated a little bit earlier where we had a microphone, a ball that was a character that was on top of a stool. We're going to take a very close look at that stool. So these right here are the sops that we're going to be looking at. And now what I would like for us to do is jump over into Houdini and walk through them, and we'll just reference things back and forth.
All right, so let's jump over into Houdini. And let's start going through that list, starting out with our box. So we can come up to the Create tab of our shelf. I will...
Oh, go ahead.
Yeah, I was going to say, I'm just going to grab this center divider between our two shelf sets. I'm just going to slide him over to the right since we're only really going to be dealing with the sort of modeling tools over here on the left-hand side.
And you want to go ahead and hide... how about the
play bar there?
Yeah.
Yeah, just to get rid of that, because we're not dealing with animation, so we don't need any frame sort of controls.
And all I was going to say just a second ago, Steve, is I want to make sure that all of our students are paying very close attention to everything that you are doing. So not only watch over here, but I want you to keep a very close eye, and I'm talking directly to you, the student, keep a very close eye over here on the network editor and the parameters as well, because all of these guys are important. All right, so with that, let's begin with the box.
Cool. So, interestingly, when we create a box from a shelf, we're creating more than just a box sop. We're creating a geometry object, and we're creating a box sop inside it.
That's right.
So let's control-click to create a box at the origin. And we can see here's our geometry node. And inside that geometry node, if I double-click to jump down inside it, we've got our box sop.
That's right. Now keep a very close eye. What changed? It now says geometry instead of scene. And look at the path gadget. The path gadget now indicates that we are located off of the root, under OBJ, under box object. So just always keep in mind, where are you at?
Cool. And we can see up here a series of parameters, and we can kind of see, look how these guys link to over here.
That's
size.
Right.
Oh, here's size. This drop down, polygon mesh is this drop down here. So if we start changing things up here, we're going to see the same changes take place over in our parameters because they are the same parameters. This is just a condensed list of our most useful
used parameters. That's correct.
So let's change from polygon to polygon mesh. We can see the change take place over here too. And what that's done, that's taken us from having a box that had a single division along each edge to now having a lot more geometry. It's a mesh of geometry. And we can change with our axis divisions parameter how much geometry we have on each face. I'm just going to leave it at 4x4 because it's going to give us enough to work with to demo some of the other tools.
Sure. This really is important in regards to the divisions because when you start out with box modeling, I mean, you can simply start out with just one face on each of our different sides, but you should really think about what it is that you're modeling to begin with and start thinking about, all right, well, if I go ahead and throw in X amount of detail, and when I say detail, that's what I'm talking about. I'm talking about the divisions. Yeah, and would it make it easier for you to begin the modeling process because you won't have to worry about going in and adding that detail by hand? Okay, so that's the box. We're all relatively familiar with the box.
Cool.
So the next one, let's jump back over to the whiteboard real quick. The next one we want to look at is going to be the poly extrude. So let's go ahead and demonstrate to them how we can extrude some faces.
Fantastic. So I'm going to push W just to bring back our shaded so that we can actually clearly see what's going on. I'm going to make sure we can see when we jump down inside our box, we switched from object select mode into component select mode. If I right click on this button, or those of you who are very used to working with this can see already from the icon, we are dealing with primitives. So since we're dealing with primitives, I can now select faces of this object, and let's grab the center face.
Okay.
And with the center face selected, if we were to come up to the polygon tab of the shelf, we can activate the poly extrude tool. And we just single click to do that. And it's going to apply a poly extrude node to that selected face. So with that, we now get a handle in our viewport, and that handle is going to allow us to interactively control some of these parameters. So the first thing I'm going to do is I'm going to grab the translate Z handle and keep an eye up here with our translate values and see how they change as the handle in the viewport is moved. So you can see I grab the translate Z handle of the handle in the viewport, and our translate Z parameter is being controlled by that. Likewise, we can now have a look and see how that face that we had here there has been pulled out and the geometry connected back to our existing model. So we've now created 4 new faces as well as moving that selected face out.
Let's go ahead and change the shading method in our viewport. Let's go ahead and show wireframe on shaded because it'll make it easier for our students to see what's going on.
Yeah, so if we come down here to smooth wire shaded, fantastic. So now we can see both the shaded model and a wireframe on top.
Now, since Houdini, in the end, is dealing with all of these parameter values that are being pumped from one node to another, let's spend just a second and talk about this group thing up here, because this is really important. See this number 22 in here? This is going to tell this node exactly what face or faces that we're going to be applying the operation to. So let's go ahead and spend just a minute and show them how we can go about visualizing each of our faces number.
Yeah, so if we come down to the right-hand side of our view, we've got a series of display options, and the one we're going to click on is to display our primitive numbers, and that's this small button with a face-looking object and a 12 written above it. And if we click that, we're now going to see our primitive numbers. Now, if we come into the face that we selected, obviously it's going to be the face on our
go back up to box.
On our box.
22.
We selected face 22, and then we applied the poly extrude. And when working in that way, it means the poly extrude is told to use a group of just face 22. So the poly extrude has only been applied to that selected face.
So change that 22 to, let's say, a 21, and then it's going to know that this is going to be the primitive that we're wanting to work with. So this one will suddenly become extruded, and this one will no longer be extruded.
Sure. So if I change this to 21, we'll now see that if we bring our visibility back down to the poly extrude, this face was now extruded.
And what if we were to do both 22 and 21?
Fantastic. So we can do that with 22 dash, that's the minus key, 21.
Okay.
Obviously 21 to 22 may have made more logical sense. But,
that's why I just kind of paused. I was like, I'm thinking backwards.
Yeah. I was just thinking we did 22 first, we did 21 second, so 22-21, and that's going to have extruded both. Now the issue with that, by default, the poly extrude, if we were to scale these faces down, and we can do that with these red arrows on the very outside of the handle, each face has been extruded separately, and they haven't been attached together, even though they were attached together originally. But we have the option to change that. We have this keep point shared option, again, that's up here as well. Currently set to no, which means these points aren't being shared, but we have a couple of other options. We can choose to use normals, or choose to use average positions. In both cases, these faces will remain attached, and their connecting faces will therefore be attached, but the two different options will affect the positioning of that center edge there. So I'm going to use average positions because that gives the cleanest result, because we have a nice straight line running all the way around in our edge loop.
Very nice. So this is just the basics of poly extrude. There is one other thing that I would like to point out. That is, let us do another extrusion, And then after we do another extrusion, let's demonstrate how we can jump back and forth between the handles of the two extrusions.
Cool. So I'll take an extrusion off the top of this one.
Okay.
I think that would probably be the easiest way to demonstrate changing our original extrude and seeing the effects it has because of the data flowing through our network. Great. So I've still got these two faces selected. So I can re-invoke the last tool that I used by pushing the Q key. So that's going to apply a new poly extrude, this time to 52 and 56, which were the new numbers for those top two faces. We can see that. We bring our visibility down here, 52 and 56.
And take a look at what happened with our network over in the network editor. A new poly extrude SOP has been added into our network chain.
Fantastic. So I'm going to grab, again, the Translate Z part of the handle and just translate that up. Again, keep points shared is turned off. And I just lost my handle, which is fantastic because now we can demonstrate getting our handles back. So if I select, let's get the handle back for our second SOP. So I select our second SOP. Well, it's automatically brought the
I'm
handle
going to
back.
make it, there you go. I'm going to hit
fantastic.
S on the keyboard real quick, and that's just going to activate our select tool. And now we're selecting primitives because of the component selection that's set up. But now let's say you do want to get back to this particular poly extrude right here because, you know, maybe you pulled this too far and you decided you want to bring the whole thing down just a little bit. So go ahead and demonstrate that, Steve.
So we want to change the first poly extrude?
The first one.
So we can single left click that guy. And with him selected, if we push enter over the view, that will both grab our handle tool such that we are dealing with the handle for this node. And notice also our parameters at the top of the view come back, whereas before they'd disappeared. And now that we have that handle, we can change the parameters interactively on this node, and those effects will obviously apply for the rest of the network that cooks off of that node.
That's right. And make sure you think about what's going on here. Look who he has selected, but look where our visibility is. Our visibility flag is set down here, meaning that we're seeing the end result of everything. And from time to time, you'll find Steve working, and he may have the visibility flag up here, but this particular node selected.
Sure.
And this is where you're going to see everything shaded up to the point in which the visibility flag has been set, but everything past that drawn out in wireframe. So you can distinguish between the two parts, taking a look at the network completed up to a specific point, and then looking at a wireframe of the rest of the network.
Yeah, it could be very useful based on which node you have visible and which node you have selected. In a certain situation, you may find that very useful for seeing exactly what's going on, what's affecting other parameters and the likes.
Absolutely. Okay, fantastic. So that's enough for the poly extrude for now. Let's go ahead and take a look at back over on the whiteboard. In fact, I'm just going to start checking these guys off. So we have now looked at this guy. We've looked at this guy. So it is time for us to look at the poly split. And remember, with the poly split, we had talked about having the ability to go in and add additional detail, meaning extra edges and vertices, into our geometry. So, Steve, let's jump back over here and pick wherever you want to add some poly splits to.
Let's do some poly splits on this face. And I will hide out our grid just to make things nice and clear. And we can do that by clicking on the grid button top right of our view. So with nothing but nothing actually selected on our geometry, we can invoke the poly split and make selections as to how we'd like to split our model. So we can do that with the poly split tool, single left click, and you'll see in the view that we now have a basically our tool is interactive and we can see the changes that are occurring when we move our mouse over certain edges. I still got that option on. So
the X basically denotes where, if you click, this is where we're going to basically be adding a new point in and begin a split operation.
Sure. And I have from earlier when we were playing around got a certain option on that means we're snapping to the center of edges, and you can get to that by right clicking, and you can see the snap to edge midpoint for the poly split was activated. So for now I'll deactivate that because that's the default state of the tool coming in such that that's not activated. So you can see when I move my mouse over an edge, we get a small X indicating that will be where the vertex is, or the vertex is created when we click. If we move our mouse over an existing vertex, that changes to a small circle, which means that we're going to be creating an edge but starting at a pre-existing vertex. So let's create a edge starting just in the center of an existing edge. So we single left click, and from there we'll get a dotted line indicating where our edge is going to go. So we can then create another new vertex, and that will generate us an edge between this newly created vertex and our second click. And we can keep working in that way, and we can keep moving around our model by single left-clicking on edges. And of course, at any time, we can push Enter, and that will complete the tool. And you can see the edges we've created. Now, the geometries that we've created is not exactly clean. We don't have a quad here or here, which means that we don't have a face that has 4 edges surrounding it. And you can see that if we bring up our points, you can see that we have 1 edge here, 1 edge here. This is our 3rd, 4th, and 5th. So this guy actually has 5 edges around him. But we can clean that up, and we can make these into quads and tris. So if I push Q, that will reactivate our tool. I can bring the mouse over to this pre-existing vertex.
And watch for it to change from the X to a circle.
If I single left click, I'm now basically continuing this edge around. So I'm coming from this vertex to anywhere that I choose. I'm just going to bring that up to another existing vertex. Single left click and push Enter. So now this guy's a quad and this guy's a tri. He's a tri. This guy's got 1, 2, 3, 4, 5 faces, so he could do with some cleanup. And you can see we can quickly come in and create detail. Without maybe some planning and forethought, we're going to probably make quite messy geometry, but
yeah.
we can quickly come in Q to reactivate the tool. I'm going to click on this vertex, and Enter. Let's come around here and just finish off cleaning up here. So Q to reactivate the tool. Single left click on this vertex, and Enter.
Now, something very important to point out, every time that Steve says reactivate the tool, take a look at what is happening over in the network editor. This is very important to keep in mind. Basically, a new poly split SOP is being added into your network chain.
Fantastic.
Okay. Do you want to go ahead and demonstrate the ability to close a path all the way around, since we will be using that?
Sure. I may undo back to... Oh, no, we should be able to make a path all the way around the bottom. I was thinking, no, this is going to mess up that path, seriously. So, yeah, you do have the ability with the poly split to close off a path all the way around the model. To do that, make sure first that you select the primitives that define that path. So I'm going to bring my component selection down to primitives. Make sure I push S so that I'm in the selection tool. And that switches back over to edges because we're dealing with edges with the poly split. So I'll just come back down, switches over to primitives. Fantastic. I'm going to grab all of these guys that define the bottom row of faces. And now we can invoke our poly split tool. And before we click a vertex, I'm going to change the path type to quad strip, since we are dealing with a strip of quads. And I'm going to tell it to close the path. And then all I need to do is create a single vertex. So I've just left click once. You can now see the dotted line indicating that we could go around and define our own loop if we wanted. If I push Enter, Houdini is going to automatically go in, and based on quad strips, it's going to close the path all the way back round to our initial point, which can be very useful for quickly inserting edge loops into a model.
And I'm going to play the role of Terry for a moment.
Okay.
So I'll be a student. So why do you have to select all of those primitives to begin with? Would the tool not be smart enough to know that quad strips and we're on quads?
I mean, in the help file, it definitely says to select your primitives, so we can give it a try.
Yeah,
but as far as I'm aware, the tool needs some form of hint as to how you want it to behave. But we'll give it a try and see if Houdini is smart enough to know. So I'm going to Control Z to back up to before we dropped in that split, and I'm going to make sure that.
Now, is this the split that we just had, basically?
So this would be that guy. So yeah, this is our split node without having been told
anything
what to work based on. So we've still got our closed path and quad strip, but we haven't had any entry into what it's actually operating upon. Because
actually, let's go and delete that node.
Okay, let's start from.
So we know that we're just going to drop a node down.
We just finished that split. I'm going to grab a poly split. Nothing's been selected. Nothing's been changed. Quad strip, closed path. Single left click on the middle of that edge. Enter. Oh wow, quad strip. It's clever enough because we're dealing with quad strips to know to go all the way around. So that saves you having to grab the faces.
That's what I thought. I just wanted to make sure, though.
Fantastic.
Cool. Okay, so I think that does a really good job of demonstrating a poly split. Obviously, everybody can see how important it is because when modeling, you're going to find yourself cutting up primitives all the time so that you give yourself additional detail where you want that detail at. So, all right, moving on from there, let's go ahead and jump back over to the whiteboard real quick. All right, so that's this guy. All right, now we got to take a break and do something easy. Let's take a quick look at Clip.
Clip is really useful for when we were wanting to delete half of a model. So in this case, well, we're not going to be able to delete exactly half of a model due to where we have our geometry, but we can delete a significant portion of the model.
We can go back up if we wanted to in our network editor and kill out all of our poly splits except for that last one.
That may explode because edge numbers and primitive numbers
are
will
going to change. So let's just go ahead and delete out all the poly splits after the poly extrudes.
Cool.
And then look at that. Beautiful. So now we can split it right down this way, perhaps?
Yeah, we can make an edge loop. I do recall that this last extrude that we made, we didn't keep points shared.
So
let's make sure that we
let's go to average.
Okay.
I'm just such a big fan of average position.
That's cool.
In most cases.
It's very, very nice. So with that, now we can run a split all the way around our model. So I'm going to make sure that I have nothing selected.
Okay.
I'm going to bring up our poly split tool. Make sure that we're dealing with a quad strip, and we're going to close the path. And I'll just drop a... And did you see what happened in the network editor? That was fantastic. We had nothing selected, so it created an unwired poly split node. As soon as I moved my mouse over what I wanted to split, it wired it into our network.
Yeah, that was very cool.
That's incredible. So I'm going to single left click on this edge and push enter, and that's going to drop a poly split. But that's not in the center of our model. And maybe there's a way of putting that guy in the center of the model. So let's delete out this node. And let's do this again. So let's make sure that we have nothing selected, just because I want to see this guy. Oh, sweet. So there we go, it's getting wired into our network. And if we right click, we can bring back that option that was on earlier from when we were playing around. We can snap to edge midpoint. And we know from the way that we created the model that the center of this edge is the center of our model because we're building everything symmetrically. So if we now make sure that we make a quad strip and close our path and create our point in the center of that edge, that's going to be perfectly in the center of our model, which means we now have two identical halves. So now we can use the clip to delete one of those halves. So I do want to make sure that I grab everything because the clip needs to know that it's working with all of our geometry. And let's make sure we're with the select tool when I'm trying to grab things. And I want to select primitives just to make it very clear that we've got all of this selected. So let's drop in a clip. The clip is going to come in with a default of the XZ plane. Let's change that. We can see that we wish to have a plane that runs along Y and X, and that will destroy that half of the model. So we can right click on the handle to quickly align to a given axis. And if we align it to the Z axis, that's going to give us an XY plane. And with an XY plane, we're now deleting that half of the model. Let's bring our visibility up here. So that was the model before. There we go. If we just select up there, we can see this is the model before, but we've deleted out that half by using the clip to say, destroy anything on one side of a plane. Now, with the clip selected, you do have the ability to keep either primitives above the plane or below the plane. So we're going to keep the primitives on that side, but you do have the option to switch that back and forth.
And as a student, just being curious, what happens if you translate it? So if you grab this guy and start sliding him.
So we just happen to have this modeled such that the center of our model was on the origin, but say you didn't, we can start translating by clicking this guy.
Yeah, there we go.
And you can see it actually...
So here's my question. Go a little bit more to the left, left, a little more, right past that, right, a little more, right there. So what happens if we take it from this point? Because geometry needed to be added in for it to actually split from that location. We've got to have edges and points, etc. So what if we were to wire this into an extrude or do an extrude past this? Did it just create our new edges for us?
I'm slightly lost with the question.
Oh, I'm
sorry.
sorry.
Can you repeat that, please?
Well, you had gone in there and created this guy right here, so that we had edges running right down the center. But it kind of looks like as you're moving this handle right here, we're getting a series of edges put in there.
It really does.
Yeah. So what happens if you bypass the poly splits? So, and here goes something cool, guys. We're now bypassing that particular guy. So now we're in here, and it looks like it adds geometry in. So the help file, while full of lots of information, can sometimes have parts of that kind of skipped, if you will.
Yeah.
But nothing wrong with throwing your own split in there.
Whoa, exactly.
Every time I model, and Zach models, and I have sat with Zach through so many videos, we always edge out where exactly it is that we want to put put stuff in. So I just wanted to throw that in there that people, and you're just, because you come from Maya.
Yeah,
So
I've got a lot of Maya modeling experience, and just yesterday Jason's like, yeah, let's poly model in Houdini. I'm like, okay.
Yeah, you guys got to understand, when Steve models and inside of Houdini, it's all through expressions.
Oh yeah,
because it's all procedural.
The power of modeling in Houdini is from its procedural nature. So when I have to model Maya style in Houdini, everything becomes a little bit foreign for me.
Exactly. So I just wanted to toss that out there. But that is very true, Steve. I just wanted to make sure that everybody understands that you, me, Zach, when all of us around here model, we always basically go in there and poly split where it is that we're going to start cutting away from.
And it also shows the true power of experimenting. Go in there, play with the tools, and you can see exactly how they work by just playing with them. You don't necessarily have to have someone else tell you how they work. Just go in there, play with the parameters, and see how they work for yourselves.
Exactly. And that's the whole idea of this video, for everybody to have fun.
Hell yeah.
Because I'll tell you what, there's going to be times that I'm going to push Steve down different alleys where there were things that I wanted to teach, but he's got to work up some lesson plans. And those might be areas that he doesn't work in that often, because Houdini is a very vast application.
Oh, it's broad.
And because of that, interesting things may happen. So I'll play the role of a student, and just like Terry used to put me on the spot all the time.
Oh, great. So now it's payback time for me. If Terry was in this seat, that would be fair. But come on, man.
You know, there's lots of love here, Steve. We all love you. Okay, so good stuff. All right, so that's poly split. That's clip. Let's take a quick look back over here real fast and see what else that we can...
We've got blast.
Blast. Because if you want to go back to the method that you had a second ago, blast would work.
And this is
more the common
this is
way.
more familiar, especially if you're coming from a Maya modeling background. So let's delete our clip. Let's unbypass that poly split so we get this geometry back in. And a more familiar method for those of you coming from other packages would be to grab our primitives. So I've got the select tool because I want to select something, and I want to select primitives. And that's to grab primitives on one half of the model.
The side that you want to get rid of?
Yep. And simply push the delete key. And the delete key creates a blast node which specifies all the primitives we wish to delete.
Outstanding. And you could see that we could go back in there and change that group ourselves by hand if we wanted to.
Yeah, so let's get rid of this 9 through 20. Let's just go in there and delete that part of the group list. And we're going to get a chunk of geometry come back.
Very cool.
So let's manually put that back in, 9 through 20, because I really don't want those guys just floating around in space.
Of course. But think of this. We do have the ability to add our own expressions into these groups. So this blast could be working off of the results of an expression that could be mathematically calculating the components we want to get rid of.
Yeah, and that's where we'll see when we come to procedural modeling the true power of planning everything out in a way that things relate to other things and we can calculate things mathematically.
Not only that, this is where everyone's going to see just how dangerous you are when it comes to procedural modeling.
Yeah, give me some maths and it becomes pretty hardcore.
I think everybody knows now because you did such a brilliant job on the bridge, and then you turned right around and the elevator. I'll tell you what, you left me in the dirt because I started looking through Thomas's network and was like, okay, let's see, how does... And you like walk back in the room. It's like, okay, I got it. Let's go. but wait a minute. I don't know what's going on yet.
Yeah. Maths is your friend. And when you're working in Houdini, maths is your best friend.
Which means I'll be sliding the whiteboard over to Steve during a lot of the whiteboarding for math because Steve's awesome with math. And, you know, I was more interested in girls during high school in those times. And in college, I was still interested in girls. And
most people are. I'm interested in girls too, but... Maths is cool, man. I mean, maths is so powerful, and it's really so useful, and it's so challenging.
And it's so important in Houdini. It really is. Okay, so outstanding. So that's a blast, and everyone can see just
That's a blast. Fantastic. That's awesome.
Oh, that was a blast. Okay, so let's jump back over to the whiteboard real quick. All right, the next thing we're going to look at is the poly bevel, and we talked about how important the poly bevel is right here when we mentioned that we don't want to have sharp edges on all of our polygons that we create. And of course, since polygons are simply the connection of these primitives to one another, very easy to end up with sharp edges. It's not as if we were working with NURB surfaces and we're dealing with nice, smooth, flowing surfaces. So let's go ahead and take a quick look at the poly bevel.
Cool. So with the poly bevel, we're going to select the edges we wish to bevel, and then we're going to apply the poly bevel tool. So I'm going to come up here, make sure I'm on my select tool, make sure I'm dealing with edges. And I'm just going to bevel the sort of front set of edges here. We could select a whole load, but this will demo it perfectly.
This makes great sense what you're doing, actually, because these edges, when rendered out, we wouldn't want them to be razor sharp. If you had a Rubik's Cube with edges like this, you could get yourself hurt.
Yeah, a bit like I really hurt myself last night on a bottle cap, which was razor sharp. Can you see?
He's showing me the cut. Wow, that's a massive cut.
Yeah, so razor sharp edges suck. is the lesson there. So
we want to get rid of these.
Yeah, and we can do that with a bevel.
And you'll notice he's actually selecting. Go ahead and select all the way around.
Okay.
Because the bevel sop is very powerful.
Yeah, and I think it's very good to have a sort of T intersection to demonstrate the true power of this guy. So let's select all these guys too. And we can grab these guys.
Once again, he is holding the Shift key down as he is adding these edges into the selection. Let's go ahead and run it on.
Work around there? Yeah, cool. So work our way around here, because again, that would be a razor sharp edge.
Yep.
Up here,
Brilliant.
and around the top.
Outstanding. And we would not worry about the inside because obviously this would be mirrored.
Sure.
If we were modeling like this.
And also, you'll notice that even if we were to select these guys, due to the fact that there's no face, the bevel won't have any effect.
That's correct. Okay, so let's go ahead and bevel.
Great. So let's click on Poly Bevel up from our shelf. That's going to bevel all those selected edges.
Ooh, look at that.
And this is really nice. See how Houdini automatically deals with all of our edge intersections and makes our geometry nice and clean. Well, as clean as possible between them. And we have the ability to change the width of that bevel with the
Look at the little
relative
bit of, I mean,
inset.
I know we're using just a little bit of just the shading method that's being used here with OpenGL is, but it's still giving us enough that we can now see some highlighting here.
Yeah.
Where we did not have highlighting before
sure.
because there was no place to put highlighting. It was a very razor sharp edge. So, okay, all right, back to parameters for the selected node. So once again, he's got the node selected down here, which has been added automatically by Houdini when Steve used the tool. And then up here are the parameters for it. So let's go ahead and take a look at that inset.
So we have the relative inset. Again, we have him available up here. I'm going to middle click to bring up the value ladder. And I'm just going to change in fairly small increments.
Look at that.
So moving the mouse left to right, we can see that parameter changing. Also over in our parameter editor, you can see the parameter changing as well.
Outstanding. That's great stuff.
Great.
So, all right, let's go ahead and take a look back over here on the whiteboard real quick. So that takes care of this guy. All right. How about the edit? Let's go ahead and use the edit real quick just to move a few points around because we can turn around in a second and mirror this thing since we've now actually created a nice half of an interesting
it's kind of
sculpture.
Like,
yeah, that's right.
It's artistic.
That's right. It's an artistic sculpture.
Wow. So,
all right. So time to pull some points. So what do we want to?
I'm just going to grab these guys down here.
That's exactly what.
But I'm not going to do them all at once because I'm going to show that the edit sop can be used to have multiple selections of points that get transformed, and it's just one sop. So I'm going to again grab our select tool. Again, deal with this time with points, and let's just grab this guy and shift select this guy. Okay. If I bring up the move tool with the T key. See, there's our edit sop dropped in, and the group filled in for us, and we can move these guys, and you'll see the parameters changing based on how we're translating these guys.
So points 0 and 2 have the following transformation information applied to them.
Fantastic. So now let's make a new selection of points. So I'm going to select this guy and this guy, and notice what's happened. We have no new edit node, but we have a different group fed in, and we have a reset series of transformations, but our existing transformation still held. So now we can apply a new transformation. We can give these guys different transformation. Maybe we want to scale these. I'm going to push the E key to bring up the scale handle, and we can scale those down. So yeah, definitely an artistic sculpture now.
Yes, it is. Okay. All right, very good. So that's edit, and edit is our friend. We will be using edit all of the time. All right, let's go ahead and jump back over here real quick. So that knocks this guy out. So next, mirror. Perfect, because, well, we have something that we can mirror.
Sure. So with this guy, let's make sure that we grab all the primitives we want to mirror. Well, that's going to be all of our primitives. And with the primitives selected, we can now bring up the mirror tool. Now we can get him from the modify shelf. So I'm going to click mirror.
And
And
now, of course, we need to...
Our settings currently are not correct.
We need to tell Houdini exactly what axis that we want to mirror this across, and not the X, which is, of course, what we get set by default.
Yeah. But we can right-click on this handle, again align the handle, and we can see we want to mirror about Z. So if we set the handle to Z, there we go. He's been mirrored. Nice. Now let's... I'm going to hide face numbers to make things as clear as possible, but I will bring up point numbers because I want to demonstrate the fact that we only have a single point number for each vertex in the mirror seam, which means that we only have a single vertex there. We couldn't grab one of these vertices and move them apart, and we don't get a hole in our object, which means that these faces are now attached. So what the mirror's done, it's not only mirrored, it's also welded or fused, is the Houdini term, those vertices together.
Though we could, to demonstrate fuse in just a second, if we want to go back up the chain on that edit, we can move some points apart. Oh, check this out. This is even better. Go ahead and select. Yeah, so we can start using the power of Houdini.
So I'm going to make a new selection of points.
So this is like we're working in the past and watching the results in the future.
But it's wanting me to make selections of points based on the mirror, so I am going to have to come back up to the edit. But
we can move our visibility down there.
As soon as we've selected those points, we should be able to. Sweet. So we can now see that by moving those points apart, they move mirror image on the other side, and we now have a hole in our object.
So move them apart just a little bit. We're just a little bit closer, a little bit closer, a little bit closer. Yeah, right there. Yeah, anywhere in there. So just in case we were modeling and we really weren't paying attention with our points, making sure that our center line stayed on the center line. I've seen so many beginners do that. How would we go about fixing that if we didn't want to have to go in and deal with hundreds of points and centering them all up, even though that technically can be done quickly with some snapping? I just want to show how we can use the fuse to our benefit.
And just to point out, you can also use the tolerance down here, the consolidate seam. So if we start boosting that up, that'll work. But we're going to use I will set that back to 0.001. We can now demonstrate the fuse sop with...
And just before we move on from this, just to kind of take what you were talking about and push it a little bit further, what Steve was getting at is this is more or less a threshold around these guys that says if they fall within this threshold, fuse them.
So really what the mirror is, it's mirroring our geometry, and then it's kind of like a fuse sop combined in with the mirror.
Exactly.
And that's going to be like our distance parameter over on the fuse sop.
That's right. All right, so jumping back over here, that's that guy out of the way. Ooh, we're getting close to doing some jet modeling.
Cool. Right.
So let's take a quick look, Steve, at the fuse.
Sweet. So with the fuse, I'm going to grab the select tool. I'm going to be dealing with points, and I'm going to grab all 4 points that we know we wish to have fused together, because this will demonstrate that distance perfectly, because the points here and here are closer together than the distance between these guys, so we can cause these guys to fuse without actually fusing into one point in the center, which is awesome. So let's come over to our polygon tab and come over to our fuse. Click the fuse to apply it to these points, and by default that distance is too small for our points to be fused together.
Because it's looking for 0.001, which is exactly what the consolidate seam parameter back up on mirror was looking at.
Exactly, but we can increase this distance. So I'm going to middle click to bring up the value slider, and I'm going to increase by very small values.
Bing, bing. Yeah, that's a great demonstration, because if you get too high, since these 2 points, they're going to all basically collapse down to a single point.
But if we make sure that we have a distance that's great enough for these two guys, it's great enough to be encompassing these guys within that distance, but not this top set and the bottom set within that distance, then we're going to see that they get fused together, but these two don't then get fused into a single point.
There you go. Very nice. All right, so moving right along, we're almost there. Let's see, next thing we got edge cusp.
Very cool. So to demonstrate edge cusp nicely, I'm going to turn off point numbers, turn off points, and bring my shading type back over to smooth shaded. And I'm going to grab the select tool, and I want to deal with primitives. I'm just going to right click and select nothing, just so that we can see our object. And we can see that everything has smooth shaded faces, and that's because all of the faces share the same points. But let's say that, I don't know, shall we make the top of the model we don't want to have smooth shaded faces, just as a good demonstration? We could come in and we could grab edges, and let's just grab these edges around the top of the model. Let's come in and grab those guys. And grab him. I'm just going to jump into wireframe, make sure I didn't grab anyone by mistake. Fantastic. So I'm just going to select these edges around the top.
Make sure you pay very close attention to the shading on the geometry right now.
Sure, because currently we're getting smooth shading running up here and over and through and down, and you'll notice this corner is being slightly shaded black due to the fact that the face on the far side is facing away from us, so he's going to get a dark surface color, and due to smooth shading, that dark surface color is interpolated up onto our top color. So you can see this far corner is black. You'll notice that change instantly when we apply edge cusp to these edges. So edge cusp is going to take, let's also bring up point numbers. Currently, each of these points along this edge, it's a single point belonging to all these edges and these faces. As soon as we activate edge cusp, we're going to get a whole series of points.
And quick deselect everything.
Yeah, I just want to deselect everything.
There we go.
So there we got our hard edge.
So look at the shading that's taking place on the actual geometry itself. We no longer have that black that's coming up and around that back vertex.
And notice where we're getting overlapping points. In some cases it's hard to see, but here we can see we've got more than 1 point. There's more than 1 point where the numbers are all overlapping.
And we're not going to see it like 20 there in the center, because that's not going to be sharing with another face that's not been basically hardened.
It's because these edges weren't hardened, just these outer edges were hardened.
Exactly.
Fantastic.
Okay, so all right, I guess we can show the tube real quick. Hang on. All right, it's like, it's as exciting as showing the box. I guess we can take a quick look at the tube. So let's go ahead and jump back over real fast.
And I'll create a tube stop, but within this geometry node.
That's right.
So I'm just going to move over to the edge. The tube's a generator, so we can't wire him off of anybody. I'm going to push tab to bring up our tab menu. Actually, this is a really nice way of demonstrating the ability to use tools both at object level and in the current context. So let's come up to the Create tab, and let's make sure that we come down to how our tools are being used. That's this button here. And currently we're creating at object level. Let's create our tool in context. Now, by creating at object level, if we create a tube, we'll get a new geometry node and a tube SOP inside. But if we come down to creating context, we're just going to get a tube SOP because we're dealing with the SOP context. So I'll control click him. Here's our new tube inside our geometry.
Beautiful.
And yes, now he's in a tube.
Now let me show this. This is really important. We see that over here, basically, the tube has been added in with the network that we've got. Where's our visibility flag right now? It's on the tube. So if we were to come back up, now of course we see everybody right now, right? But if we were to come back up, the object itself is just showing the tube, not our artistic sculpture that we've been working on for the last half an hour. Bummer. What if we wanted to see both? I mean, when modeling, generally, you're going to work on one part. Like, let's say, for example, we did a table. So you could start out with a tube, and then we could duplicate that tube. So we've got 4 legs, and then you're going to want to come in and drop in a box real quick. And so now you have all of the elements of a table. But if you were to jump back up to the object level, you're only going to see the node that has the display flag on it. And you'll also see that if we hold shift and we come in here and try to add a flag to the selection, we cannot do that. Okay? So this is a great time, Steve, just to demonstrate a merge real fast.
Yeah, and you'll also notice the only reason we're seeing this guy is because he's been turned on to...
He's been templated.
Yeah, and it was control-click template as opposed to normal template, which makes it a selectable template, and hence it's not wireframe. So if we turned off the template, we'd only indeed see the tube. But we can use a merge sob, and that's going to take 2 different branches or more. You can have as many wire into a merge as you like, but multiple branches of data and merge them into just a single branch of data.
So merging is your friend. You're going to be using merge sops a lot when generating sops.
So I just pushed tab there and typed merge to grab a merge sop from the tab menu, pushed enter to create him. Now let's grab our edge cusp. Let's shift select our tube, and if I single left click on either of their outputs and then single left click on the merge's input, we're going to wire both into the merge, bring our visibility down. Let's turn off point numbers, clean things up.
And it's just merged all of the geometry such that if we jump back up, look at that. All
so
right.
now our merge is our geometry, and since our merge contains both our funky sculpture and our tube...
Funky sculpture. Artistic sculpture. Get it right, Steve.
Funk is artistic. We're not going to have a music argument now, are we?
I hope not. But we can see everything. Let's go ahead and jump back down into the box object. All right, having the ability to merge things together like this is really nice, because now if we were going to do a lot of modeling with the tube, we could focus on just that particular branch of the network without having to be bothered with all of this other stuff. And that's very convenient, and you're going to see that we're going to do that a lot as we work with models inside of Houdini. Now let's spend just a second and talk about just a couple of the parameters, like the ability to control the radius. That we got a bottom radius, or we got a radius 1 and a radius 2.
Cool.
Let's show that, the height, and maybe the ability. Of course, we all see that we can change the primitive type.
Yeah, because currently he's primitive, so we're not dealing with polygons. We're dealing with a mathematical type.
Yeah.
In a way. It's unique to Houdini. It's Houdini's way of representing a tube as a mathematical data type.
Exactly.
So we can change our radius, and we have the ability to change both the top radius and the bottom radius independently.
So if you needed a cone, done.
Or you want like some afterburner thruster or something.
Exactly. Very nice. And the height, of course. Excellent. And then, let's see, only really one other thing just to show real quick is, what if you want caps?
Cool. So yeah, we can come over to the detail tab if you do want caps, and we can check end caps.
Very nice. Now, there's some other things dealing with our divisions and all. We're not going to get into that right now. It's just like the box, basically. We have the ability to change our primitive type over and then start adding different levels of detail into our geometry. But again, just like the box, and we'll worry ourselves with that just a little bit later. So, Steve, excellent job, my friend. That takes us all the way down to the tube. We've now taken a quick look at everything. So what I'm thinking is we're going to jump back over to Houdini, and I say, let's model a very simple jet.
That sounds like an awesome plan.
Missiles.
So I'm going to jump back over into Houdini.
All right, Houdini.
And as much as we loved wow, now our sculpture's really crazy with the tube change like that. As much as we love this guy, I'm just going to hide him out and deal with a new geometry object to create our jet.
All right, so a very simple jet. Please do not spend forever modeling. We just want to demonstrate some basic modeling.
Yeah, now we can see some of these tools in action.
Awesome.
Fantastic. So I'm going to push tab and bring up a new geometry node.
Now notice he's working differently this time, as opposed to just using the tools that are available at the top in the shelf. Steve, this time around, I want you to start using the tab a lot more.
That's great, because I really love the tab menu. So let's jump inside that. Let's rename that geometry, because Geo1 does tell us nothing.
Let's call it jet. All right.
I'll jump inside and delete out our file, because we're going to be creating our geometry
and
from
we always
scratch.
get a file stop by default, unless you make some changes to the
Yeah, you can make changes to stop bringing that in, but it can be useful, so I leave it in there. So let's start out with a box.
So he begins typing out box. There we go.
And enter again to place the box. I'm going to deal with a polygon mesh, because I want to set my divisions. So I want 4 divisions, giving us 3 faces, because it's specifying the number of vertices. 4 divisions in X, and only 2 in Y, and 2 in Z.
Now, what makes you want to put that in? I'm going to play the role of student again.
It's just me thinking about how I'm going to approach this jet.
Okay.
And I know that the jet's going to basically have a body section. That's what I'm going to create first. And from that, I want to bring out the cockpit. And I want the cockpit to come out at this face with 2 thrusters either side.
Okay.
So I know I need 2 thrusters and a cockpit, so 3 faces will facilitate that very nicely.
So our alignment of this jet then is going to be in the positive Z direction.
Yeah, positive Z is going to be the forwards-backwards direction of the jet.
Excellent. Okay.
Great. So now we can resize this guy, and we can resize him using the handle, which is really cool. So you see, as we start scaling this guy down, it's just changing the size on that box. So I'm going to flatten this out in Y, something like so.
Now, many of our students following along may have simply control-clicked on the box up from object level, and then thought that they'd follow along by simply scaling that object down.
And that would be bad, because in this case you can see that we've scaled down in Y and up in Z, which means that the proportions of that scale, well, it's not in proportion. So up at object level, you'd see that your scale values wouldn't be in proportion, but our jet currently is going to be modeled in proportion, so it would be very important to have our scale values in proportion, because you don't want to think, oh, okay, so this is actually a jet who's 4 times longer than a normal jet because we've got a scale for it in Z. We want to have a nice in proportion scale.
And we can introduce some very unique problems by scaling up here and then parenting things into it, where the parenting is going to basically inherit those scales.
And we also see that the scale will have an effect, and all our handles in the viewport will get scaled as well, which can be very frustrating.
Yep.
So I'm going to jump back inside the jet by pushing Enter.
Remember, when working down inside this geometry node, here we're modeling. But we haven't, don't try to position the model where you want the model to be from down inside a geometry node.
Yeah.
That's the job of that geometry node up at object level.
So inside the geometry node, all we're concerned about is at the end of the day, having a jet model.
That's
not
right.
positioned for our scene, not animated for our scene,
That's
just
right.
a jet model.
Okay, very nice.
Fantastic. So I'm going to grab this front face and extrude him out. So let's make sure we're in select. We are indeed selecting primitives, so I'm going to grab that front face. And sometimes it's easy to select when you're in shaded mode, hence changing. I'm going to bring up the extrude, and I'm going to do it in our view pane, again using the tab menu. If I push tab over our view, and I can type poly extrude, or I could have come down to our history and grabbed poly extrude. And that will apply a poly extrude to our selection. And let's just extrude him out and scale him down a little in Y and in X2, so it's nothing that you guys haven't seen earlier. I'm going to push Q to repeat that operation. We get a new poly extrude. Let's just bring the cockpit out again. Scale it down slightly, and in this case I'm going to translate it down slightly just to give some shape to the cockpit. It'd be nice to have a window on the cockpit, so I'm going to select this face by single left clicking Q to repeat the poly extrude. Bring this up and scale this in slightly. Great, so before we continue modeling, I want to delete half of the model, just focus on one half and model that half. And we've seen the technique we used earlier on the box. I'm going to take the exact same technique. I'm going to use a poly split to run a edge loop all the way around our model, just because I like to outline where we're going to be deleting anyway.
Okay.
And then I'll use the clip to delete that half.
Okay.
Does that sound good to you?
If you want to, I mean, my thought would be if you want to run the poly split all the way around, as you're comfortable with doing inside of Maya and all, I just blast.
Just use a blast?
Yeah.
That sounds fantastic. So let's bring up our poly split. So I don't need to have anything selected, as we saw earlier. Bring up the poly split. Enter. Before I click anywhere, I'm going to change it to quad strip close path. And do we have our... We still have our center edge snapping, so the edge midpoint, that's great. So I'm going to single click on this guy and push enter, and that will run that edge loop all the way around the center of our model. So now I'm going to come in, grab the select tool, make sure that we're working with primitives. I'm going to use a top view for that, so if we push space 2, we're now in a top view, which is going to mean that it's very easy to select one half of the model, because this guy will be a vertical line right down the center of our object. I'm going to push delete. That will drop in a blast node and delete out half of our model. And now I can push space 1 to go back to perspective view.
Very nice. And as you're working shaded, let's go ahead and turn on the wireframe. Yeah.
Great. So let's work on the tail now. We can see currently we just have a big face along the back here, and that's not really enough detail to bring the tail out of, because we don't want the tail to be attached here and go all the way back. We really want him to come out from about here.
But it'd be such a cool looking jet. Okay,
I don't know how well it would fly.
No, I'm being sarcastic. It wouldn't look good. All right, so
I was going to say, if you really want me to bring the tail out, but that would kind of look weird. So we can use a poly split again. So I'm going to push... Well, no, we just did a blast, so Q would blast, and we don't want to blast with nothing selected. So let's bring back our poly split. This time I do need to make sure that we right click and turn off snap to edge midpoint, just so that I can position this guy over here. So let's make sure we're creating another closed quad strip. And around about here I'm going to single left click and enter, and that will generate an edge loop around the back of our model. So now that we have that, we can bring a face out of here. Now you may also ask, well, why didn't I just split from here to here to give me the face to extrude out? Well, it's good to try and keep everything as quads, as mentioned earlier, and by inserting an edge loop all the way around this guy, and then subsequently all of these guys will remain quads, whereas before this would have become a face that had 5 edges. So with that, I'm going to grab this select tool, come over to primitives, grab this back face, and then we can tab from the history. I'm going to grab poly extrude. That's going to allow me just to extrude this face out. I'm going to move him back slightly, scale him down some. And we'll delete this inside face, because if we're mirroring, we don't want to have internal faces, because that would be bad, especially if we then try to fuse everything together. These guys will not fuse due to that face that's in between.
Okay.
So I'm going to select that face and delete, and then new blast is in place and deletes out that face. And I do want to narrow this guy out at the top and work a little bit more to refine the shape. So I'm going to grab the select tool and come over to points, grab these guys, grab our move tool. Let's move them over a bit. Let's maybe bring all of these guys forward a bit. And you can see all of this work is utilizing the edit sop. So something like that.
Mm-hmm.
Great, so that's the tail. I'm happy with the tail. So let's now bring a wing. Did I even do the thrusters? No.
No.
Without thrusters, that jet's really going to struggle to get off the ground. So let's work with thrusters. So primitives.
So let's work with thrusters. I was almost expecting to find a thrusters option in the menu there.
That'd be so cool. That's kind of like, the age-old joke of the make Pixar animation button in a 3D app.
Exactly.
Yeah, that would be really useful, but it's actually not that hard to make thrusters. We
No.
can do a very simple extrude, and we can get some nice thruster detail.
Mm-hmm.
So I'm going to push tab, bring up a new poly extrude. Maybe in, Houdini 25, we might have a make thrusters button. So let's scale this guy down a little bit. Q, and I'm going to uniformly, by clicking on this outer red arrow, scale down, and then Q again, and drag this guy in. Cool. So now we have a thruster. Now let's make the wings, because that would have been a massive oversight. So I'm selecting these two faces that are going to define our wing. And again, let's work with an extrude. So Q. And I'm going to undo that movement, because I really did not want to move them. So let's pull this out a little bit. Just scale it down a tad. And you can see that our faces aren't keeping together, so we can simply use average positions. Awesome. So Q again, and then we can bring new detail out from these guys. Let's pull this out for the bulk of the wing. Let's move these back slightly, scale them down. Again, we need to make sure that these stick together. Scale them down in Y also. And let's move them down in Y. Maybe still a bit too wide in X. So let's scale these guys down some more, shift them back. I know I'm being really picky.
It's all good.
So,
but are you having a good time?
modeling's a lot of fun.
Good.
Procedural modelling is more fun, because it's challenging, but modelling is a lot of fun. So, great. So let's extrude off the end here and create, as I learnt yesterday from Jason, let's create the winglets.
Yep.
Which, yeah, you learn everything, at least something once a day. So
At least hopefully everyone does.
yeah, I'd really hope so.
Life so much more enjoyable.
Especially when it's really random information. Because, I'm not a knowledgeable person over planes. The planes aren't my forte, and I learned something really random about planes, so it's kind of cool. It's average positions, and let's slide this back. Talking about planes, it would be really good when you get your plane license all back up to scratch. We'll definitely have to go for a flight.
That'd be
awesome.
I really think you will have a tremendous time.
Fantastic. So with that, all that's really left to do is bevel some edges, mirror this guy, and then the jet's going to be a wrap.
Awesome.
So let's bevel pretty much all the edges that we think would be hard edges currently. So I'm going to grab edges. And that's awesome. Those guys are already selected. I will control deselect him, and then let's go into wireframe, because it's going to make selections very quick. So I'm just shift left click dragging to grab all of the edges around the wing. I want to grab that edge, and I will grab the underside but not the top side, just because I feel there should be a definition here, but I'd like that to flow smoothly. And that's just a personal preference. I mean, feel free to grab different edges.
Experiment. Have fun.
Exactly.
But don't do that.
Yeah, I just, made a selection and didn't have shift key held down properly, and it, lost my previous selection, which is what the tool's supposed to do. Let's grab you and under here. And again, awesome. So let's come along the back here and up onto our...
Just wireframe grab all that on the tail.
Yeah, that really would make life a lot easier. So we can grab all of the top here, because it doesn't matter if we try and bevel those inner edges. So I'm going to Control Shift and just go
Nice.
grab you. I do want to grab you. These guys. And let's have a look. We do want to grab the edge of our thruster. I won't worry about the inside of the thruster because that guy's going to be pretty dark if we were to, you know, shade this guy and everything. Let's grab around our cockpit and running down the nose of the plane. Oops. I think that's pretty much everyone. Any edges you see there that you'd like to
No, that's
add?
good.
This demonstrates using bevel nicely anyway, so we can push tab and bring up. And it's going to be poly bevel, not just bevel. So poly bevel. And that's going to bevel those edges. Did Houdini try and bevel that inner edge? Wow, so there's me going from my Maya days of beveling and thinking that Houdini works slightly differently. The great thing, we can look to see which edge we selected, we can go back and we can remove it from that group and stop that problem. So it appears that Houdini will bevel an edge even if there isn't a face either side of it, which is interesting behavior, but that's how the developers have chosen to build the bevel tool. So let's deal with that now. Let's come back up to our extrude and let's look at the point numbers that define that edge. That's 31 and 17. That's a lot of points going on. Hunting for 31 and 17. There we go. There's 31 and 17. So if we come in here and delete those out, I think I need to delete that 7 as well, accept. So he's no longer beveled. Our bevel is giving us a warning. What I might just do is push the backtick and make a completely new selection. Or do you want me to go in and work with the numbers? Because I think it was selecting an edge all the way around 30. If I could see the point number, 26, 30. Yeah, 30 and 26 is probably not too pleased about either. Let's get rid of all of that. And did I put a space somewhere else
I
by
think you
accident? Did. Let's go back from the start. I can't imagine that being an issue, but let's just scan through. And obviously this is far more technical than maybe if you were just working in the viewer, but it's going to save us a lot of time from having to select all of these edges again. That looks good to me. Fantastic.
Now, before we go on, let's go ahead and explain. They saw two things that they have not seen in the past. One, when you brought up the expression editor.
Yes.
So let's go ahead and just talk about what you did, because to them they were like, wow, everything just changed.
That's very cool. So when you're dealing with expression fields, channel fields, like here with the group, you can push Alt and E, or you can right click, come down to expression and say edit string. That's going to bring up the expression editor, which is basically a bigger window that allows you to see more clearly what you're dealing with expression wise.
And then what Steve just did, as he's so used to working with the raw data, is he just, instead of wanting to go back in there and work in the viewport, he wanted to just remove those numbers out by hand.
Yeah, because all of the selections that we made in the viewport before we activated the poly bevel, they became this group parameter. They became this rather interesting looking string of text. And I knew that basically you're specifying edges by a series of points, so I knew that I could go in, I could look at the point numbers for the edges that we selected but didn't want, and I could remove those from this string, and that would remove those as if we'd never selected them.
Exactly. So go ahead and close that. There was one more thing that you saw, and that was when you middle clicked on the node when it was giving you the warning.
Yeah, wow, I do things without even realizing I'm doing them. Yeah, I got a warning, and to see information about a node, including warnings that it's throwing up. If you middle click on a node, you get a whole load of information. You get information about the geometry that's going through that node. If you have groups and things, as you'll see in the future, you'll have information about those. You'll also, if you get warnings or errors, they'll appear in the information.
We had some invalid groups in there.
Yeah, so from that I knew that obviously I'd made some form of mistake in that changing the string, so I could go back in and fix it.
Brilliant. Okay, and you did fix it, and everything is now working great. So let's go ahead and turn off our point numbers and look closely at the beveling that's been done, and then once again demonstrate that we can use the inset to control
Yes, we can.
the amount of beveling. Very nice.
Let's make that kind of tight. Great, so shall we mirror this guy over?
Absolutely.
Fantastic. So I'm going to grab all of our primitives, push tab, and type mirror. I'm going to use mirror as a utility, and that would be the same as clicking mirror up on our tab menu. And you'll see, here's a great way to use the fuse, because these guys have become separated. But you'll see that if we bring up point numbers, the rest of the model will just have single points along that seam. So now that we've mirrored, let's deal with fusing those guys back together. And we have some interesting interfaces, so I'll deal with deleting those by grabbing the select tool. And if I do that before we go into the mirror, then we only have to do it the once. So I'll blast him.
Very nice.
Great. So now we can come in and fuse these points together. So let's come down to our mirror. Let's make sure we're selecting points. There's a whole load of points up here. I'm going to do that before our mirror. Obviously that poly bevel wasn't quite fixed as much as I thought it was. There's still some interesting issues, but nothing that you can't fix. So I'll come in here, grab these guys, and I will tab fuse. And let's increase our distance up. And that will just form all those into one point. And then we can come down to our mirror. And now we should just be dealing with a pair of points here and two pairs of points here. So now we can fuse these guys together. So let's make sure we're selecting points. Now I can see that we may well have difficulties getting these guys to snap together in the same selection as these guys due to the fact that this is almost square, so those distances are going to be getting very close.
Very close, yeah.
So I'm just going to do these as separate operations. Now we can grab these guys in because they're very far apart. Tab and fuse. And if I bring the distance up, we'll snap those together, and then let's just grab this guy and this guy, tab fuse. And that will bring the distance up for him. And so now he's snapped together also. So now that's the seam of our model. And finally for the jet, I just like to use an edge cusp to pretty much give everybody hard edges, just so that we can have a nice crisp model, because that's the design that I want to go with our jet.
Go ahead and turn off our point numbers real quick.
Great. So if I also make sure we're selecting primitives and turn off our wire on the smooth, you can see this is the model currently. If I feed him into an edge cusp, it's going to want us to select all the edges we want to cusp, because of course you can activate a tool then make the selection in the viewport. So once you've made the selection, push enter on the keypad to activate that. And that's going to cusp all our edges. So that is the...
Go ahead and deselect real quick. Everybody can get a quick idea of what it looks like. I'll shade it up.
And because we're in edges, it's going to show us edges. There we go.
Nice.
That's pretty cool.
All right. So let's go ahead and jump back up a level.
Sure. So now we can jump back up to geometry level and sculpture.
So a missile.
Yeah. So we're going to build a very simple Sidewinder type missile. And obviously that's going to start out as a tube. Now, I don't want to build him down inside our jet geometry object.
Exactly. And why not, Steve?
Because that geometry object represents an object. A jet is an object. A missile is a separate object.
Well, you got to ask yourself, is there the possibility that the missile would ever be used in an animation or as a standalone object? And in our case, I'd like to animate the missile coming loose and taking off in the future. So in that case, it would be great if it was a separate object. Otherwise, we would be forced to deal with its animation down at a lower level.
Yeah. But yeah, I mean, if we were having a model where we knew we were never going to have those missiles leave the jet, then you would be more than free to model it all under one geometry node. But since we know we want to have our missiles leave the jet and act as if they're separate objects with their own transforms, we're going to create it in a new geometry node.
Okay, sounds great.
So again, I'll drop down a new geometry node.
And name it.
And I'm going to name this guy missile. And if we jump inside, I'm going to delete out the file. And that was space H to home up on the node.
And this is where we can spend a second and talk about visibility of other objects when working down inside of a geometry node.
Yeah, so currently I've got my settings to hide all of the other objects out. And we can come up here to change our visibility options. By default, I believe Houdini comes in with show objects, and we're seeing our jet but not our sculpture, because our sculpture is hidden because we've unchecked the display flag.
That's right.
But our jet isn't hidden. Our jet does have the display flag active, but he's not our object. So if we show all the other objects, the jet being another object, we're going to see him.
And we can also ghost them as well,
which gives us sort of like a 50% opacity. But I really like working when we're dealing with just an object and we're working with the details on just that object. It's nice to work with simply everything else hidden. And in this case, we're working on just the missile. Right now, it doesn't matter about the jet. We'll just build a missile.
And it also doesn't, in case anybody's wondering, but what about the size? Don't you want that size to match the jet properly? In this particular case, no, because after the missile is created as geometry, we can then go back up to object, and that is where we can indeed scale it, so we can scale it to fit right.
Because if we build the missile down here in proportion, it doesn't matter if we scale it at object level. I just didn't want with the jet to have really odd scale values when our jet was actually in proportion.
That's correct.
Great. So we can start with a tube. And I'm going to work with a polygonal tube so that we have access to all of our faces and the like, so we can do extrusions and all the operations we've seen currently. I will align this guy with the z-axis. If we remember, our jet is aligned along the z-axis, but it wouldn't matter if we built this on another axis because we could rotate him into position. Right. I will drop our radius down slightly and boost our
demonstrate what you just did real quick, because everyone knows from the beginning when working with a tube we have the two different radiuses, and one controls the top, one controls the bottom, so you can get cone-like shapes, but somehow you just magically control both at the same time.
Yeah, the radius is kind of like a special parameter. It's a bit like when you have translations, rotations, and they are tied together such that you can click on just the name with the middle mouse button and change both of them at the same time.
Very convenient.
Which is really useful because obviously we want this to remain a cylinder. So, scale them out to something like this. This is going to become the middle section of our tube, and then I'm going to just basically use extrusions for the most part to build everything else. Now, currently we don't have end caps, so that's going to make extruding those end faces very hard. So let's check end caps. And also, our detail, we currently have 10 edges running around, and that's our columns parameter. I know that the fins I'm going to be building on the missile are going to basically be at quarters, so I'd really like to have a multiple of 4 in the detail. So I'm going to use 20, which doesn't give us too much detail, but it does give us a multiple of 4.
So every fifth face we can extrude, basically.
Yeah, and that will give us nicely organized fins such that they're at quarters.
Top and bottom, that's opposite?
And left and right.
That's opposite, exactly.
Fantastic. So now that we've got a tube, we can start working with this guy. So I'm going to select this end face, and I'm going to extrude this backwards to give us some detail that we can bring the back fins out of, give us a little bit of extra overlap from there, and then give us a thruster.
Okay.
So I'm going to tab, and poly extrude is on our history, but it's off the bottom of the screen. But if it's not on the history, you can simply type him in to get him. So I'm going to let's work with our shaded over the top of the wireframe.
Nice.
So this is going to become the center, like part of the missile. This is going to be where the back fins come out of. Q to reactivate. This will be like the overlap for just beyond the back fins. Q to activate again. I'm going to uniformly scale this inwards. Q to activate again. Slide him in to give us kind of like a thruster.
Excellent.
And you can see we're getting our soft edges around here, so I'm going to grab this edge here, and you can see that we get a little arrow indicating like edge flow. So we can right click in free space and say select loop. That's going to grab that outer loop. And we can do the same with the inner, so I shift select an inner edge, and we can come down to select loop. And with those two loops selected, I can tab and do an edge cusp, and that will harden those edges up. So with that, let's bring out our back fins, and then we'll deal with the front of the model. So I'm going to make sure I'm selecting primitives. And let's grab a primitive that's close to the top. It doesn't matter if it's off slightly because we can rotate this guy around. And as we said earlier, we've got 20 faces, so divide that by 4. We're going to have 5, every 5th face being a fin. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Slightly missed one. Hang
I think the one on that side.
Oh, he's one too low.
Yeah, there we go. Excellent.
Fantastic. So with those guys there, we can now extrude these out. So I'm going to push Tab, grab our poly extrude from the history, bring these guys out, and let's scale these guys down slightly and scale them in as well. Awesome. So now let's take out the front of the missile.
Push that down just a little. Up a little more, right there.
About there?
Yeah, that's good.
Cool. So now let's bring out the front face of the missile. I am going to extend the sort of center shaft of the missile slightly before we have fins, so I can do that. I'll just grab this guy, you see the edit. Whee!
Good stuff.
Let's just grab all of our points then. And shift those forwards. I'm guessing when we created edge caps originally it was edge cusps, so we were getting separate points for each face. Something like that, and then bring the front fins out.
Sure, looks great.
Look about good. Cool. So let's grab our primitive, our face, and extrude. Pull this guy out. And I'm just going to give, again, enough room for our sort of fins. These guys are going to be slightly longer than the back ones. Q to re-invoke. A little bit of overlap after there. Q to re-invoke. This is going to become the tip, so I'm going to scale that down. And Q again. And scale that down. And I'm going to, this time, leave this with smooth shading such that if we come over to smooth shading, we get a nice rounded off end to our missile. So let's come back over, bring back our wire shading. Let's grab the fins. Now this time I want to make sure that I follow down so that I grab the face that corresponds with our other top fin. And now we can go round, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Fantastic. So now we can bring these fins out. And these fins are interesting because they're going to extrude outwards. They're going to be offset backwards. Oh, that's scaling. Offset backwards. And notice what happens. Due to the normals of the face, these guys get extruded in different directions. And this is something that quite often crops up. So often, in fact, that it's as easy as changing a parameter on the extrude to fix the issue. So we have this local symmetry parameter. And if we set that to the y-axis, and we can see from the handle that the y-axis is where we wish to maintain symmetry, that's going to make all of these guys follow the handle. So let's just scale these in a tad, and in a tad, something like that. And with that, I mean, we could spend time beveling edges and things, but you've seen how to do that.
So it's kind of big. Yeah, something like that.
That's cool.
Cool.
So, yeah, we've seen that we could bevel edges.
Oh, yeah, that's good enough. That's good
everything,
enough.
But
sweet.
Awesome. So now we have a missile. So I will turn off that. So now we can jump back up to object level. He's huge. The jet is very tiny. But that's
almost
cool.
looks like that's part of the missile.
Yeah, and it's got like little mini thrusters. That'd be one awesome missile, dude.
No kidding.
That's really kind of cool. Kind of like something that Stark might, you know.
Yeah, no kidding.
Hell yeah.
Tony Stark. All right, so now we're ready to take and treat this as an object. So now you can scale it and position it into place with the jet.
Very cool. So let's grab our uniform scale since we know he's in proportion, so we're going to just scale uniformly. And let's drop this down. Something like this, we can always change it afterwards. I'm going to grab the move tool, and we're going to be dealing with moving at the object level. So, yeah, he's still way too big. That's probably better. Let's position him somewhere under our wing. And I will rotate him so that the fins cause... so kind of would not be sticking up into the wing. Something like that, maybe
move him up
slightly closer. And you notice now we've rotated, our move handle isn't aligned with world, it's aligned with the object, which usually can be very useful. If we don't want that, right click on the center of the handle, come up to align handle, we'll just align that back with world. Fantastic. So now that we've got that guy in place, we can say Control C to copy him, Control V, we get a second copy, and let's just slide him over to the other wing. Cool. So now that we've got 2 missiles and the jet in place, we can take a very quick look at parenting them together.
Yeah, they've seen parenting.
Yeah, that's very cool. So our jet obviously is going to be the parent, the missiles will follow with it, so let's wire our jet into those 2 missiles, grab the jet, and now if we move the jet about, our missiles come along for the ride if we rotate our jet.
Excellent.
And with that, that's pretty much everything I wanted to show in this video. Are you happy with the video?
Yeah, very much so. That's a lot of things we've looked at, Steve, which is really cool. I mean, we've done, I think, an excellent job, especially you, covering all of these different surface operators. So we've looked at the box, the poly extrude, the poly split, the clip, the blast, the poly bevel, which I spelled with an A. That's awesome. Let me, yes, there we go. Let me throw that E in there. So the poly bevel, the edit, the mirror, the fuse, the edge cusp, the tube, a lot of different things that we've looked at. What I would do at this point is encourage all of our students to play with these various surface operators that we have demonstrated. Just play with them. Try to come up with, build a lamp, build a laptop, build a cell phone, build a keyboard. Just start trying to build simple things and start working your way up. But with that, keep in mind, finally, that this was just an introduction to basic polygonal modeling. We haven't taken into account the true power of proceduralism yet. That's coming up with an introduction to procedural modeling very shortly. And with that, that will wrap up this video. Thanks a lot, everyone.